Good morning, my dear friends. See now, this is the last problem in this chapter now. Okay, I will read this problem now. A PSC beam of uniform rectangular cross section and span 15 meter supports a total UDL of 27200 Newton. Okay, in sense he has given the span as well as the total UDL. Okay, excluding the weight of the beam. In a sense, this excludes the weight of the beam. In a sense, this is only the live load. Okay, determine the suitable dimensions of the beam and calculate the area of tendons and their position. In a sense, you have to design it. Okay, the permissible stress in concrete in compression is 50 Newton per m square, and in tension it is 1 Newton per m square. In a sense, this 15 Newton per m square, this itself is your FCCI as well as FCCF. Okay, because he says the permissible stress in concrete in compression. He says, in sense now it is in initial condition also it is same, and in final condition also it is same. FCCI and FCCF, and permissible tensile stress is 1 Newton per m square. Okay. Also he says the permissible stress in tendons is 1050 Newton per m square. In a sense, he has given directly the permissible tensile stress in steel. Okay. So now, as usual, we shall first of all will take up this preliminary design now. Okay. So now, I will first calculate the live load moment ML. Okay, it is WL L by 8. It is not L square. WL L square by 8. Okay, actually. But since he has given here the total load, see now, he has given total load, live load of 27200 Newton. It is not in a Newton per meter. Okay, so it is the total load. So it will become now WL L by 8. Okay, so WL I know, span I know, divided by 8 will give me so much Newton meter as the live load. And now, once I know the live load, now I will start calculating the approximate depth required. Okay. So the beam depth may be taken as 1/15th to 1/10th of the span, because you have already seen in the preliminary design. Okay. So approximate depth I will take it as 1/20th of L. Okay. 1/20th span I know 15 meter, convert it into mm. So it will give you 750 mm, or say 800 mm is my total depth required approximately. Okay. Also width of the rectangular beam, and now we will take a decision to go for a rectangular beam now. Okay. In the last problem, I think we have gone for a I section. Now we'll go for a rectangular section. Okay. So but now the width of the rectangular beam is given by L by 30, if I am right. Okay. So L I know, span divided by 30 will give me 500 mm, say 550 mm. In a sense, I will adopt the width as 550 mm. Okay. So now, therefore, our cross section is now 800 mm by 550 mm. Okay. So therefore, area can be now easily calculated. 800 into 550, it will give me 440000 mm square, or 0.44 meter square. So now once I know this area, I think I will start calculating this dead load WD. Okay, dead load WD can be now easily calculated as 0.44. It is the cross sectional area into 1 meter along the span. It will give me the volume. Am I right? Volume, it will give volume into density of concrete will give me 11,000 Newton per meter as your dead load. Okay. So now once I know WD, okay, so now I think I can easily calculate MD. MD is given by WD L square by 8. So WD I know, it's here. Span I know. Okay, you will get MD. Okay. So now MD I know, and ML is also known to you. Am I right? ML also you have calculated. So once I know MD and ML, I think now total moment MT can be now easily calculated. It is MD plus ML. So it will give me so much. Okay. So now, once I know MT, I think MD by MT ratio can be now easily calculated. MD by MT ratio will give me 0.37. Okay. And you know that it is greater than 0.2. In a sense, MD by MT ratio is greater than 0.2. So now once I know this, okay, now I think I can easily fix up the approximate effective press stress. Effective press stress PE. It is given by MT divided by 0.65D. Am I right? So MT I know, 0.65D I have fixed it up as 800. So it will give me PE as effective pre-stress as so much. Okay. So now once I know the effective pre-stress, now I will try to calculate how much is the initial pre-stress required PI. Okay. Initial pre-stress is given by effective pre-stress divided by eta. Am I right now? Loss effective. But now, since in the problem he has not given anything about the loss, you can assume some loss. So now I will assume the loss as 20%. Okay, when I assume the loss as 20%, so eta becomes 0.8. Am I right now? So now you know PE value, zero point 0.8 is your loss factor. Am I right? So it will give me the initial pre-stressing force. Baba, this is your approximate final pre-stressing force. This is your approximate initial pre-stressing force. Okay, PE and PI. Okay. So now once I know PE and PI, so now we shall start calculating uh, required area of concrete AC. Okay. So now required area of concrete AC is given by PE divided by 0.5 FCCF. This is the equation which you have seen in your preliminary design. So PE I know, 0.5, FCCF value is 15. So you will get 210096 mm square. Okay. So but now, this is the area of concrete required. Okay. But how much area you have given? You are given 44000 mm square. Is it right or not now? A rectangular area you have seen earlier that when you fix up 800 mm by 550 mm, okay, area provided is now 44000. It's very, very high. Am I right, sir? Now it's very, very high as compared to this. So now, as you see, I need an area of only 210096, whereas I have given 44000 like this, 44000. It is too high, almost double. So now since it is a double, it's going to become highly uneconomical. So I will try to reduce the cross-sectional area now. Okay, I will reduce the cross-sectional area. So now let us provide a section of 600 mm by 450 mm. Am I right, sir? Now 600 mm by 450. So now AC is now, in sense now provided AC is now 600 mm by 450. It is 27000 mm square, or it is 0.27 meter square. Okay. So WD can be now easily calculated. Cross-sectional area into 1, it will give me the volume into density. It will give so much. MD can be now easily calculated now because you know WD. WD L square by 8 will give me your WD. MT is MD plus ML. Okay. MD you know, ML you know, it is so much. Now MD by MT ratio can be now easily taken now. Okay. So MD by MT ratio is now will give me 0.27, and again it is greater than 0.2. Okay. So now everything is now revised. Am I right, sir? Now. So now what for this revised things, now I can easily calculate the effective pre-stress PE. Okay. Again it is MT by 0.65D. MT you know, 0.65D you know. Okay. It is so much. And initial pre-stress also can be now easily calculated. It is PI is a PE divided by eta. Okay, it is so much. So now once you know PE and PI, now I can calculate required area of concrete AC. So it is PE by 0.5 FCCF. So everything you know, it gives me so much. Okay, so now see now this area of concrete, okay, how much you have given the area of concrete? 27000. Okay, so you have given more area than the required. Am I right? It is 239263. Am I right? How much you have given? 270000. Okay, you are given slightly more area than the required. Am I right now? So now I say that the provided area of this cross section 600 mm by 450 mm is okay. Okay, in sense it is slightly greater. Okay, so I say that this area is okay or this cross section is okay. Okay, so now with this we have completed the preliminary design. Okay, now we shall start with the final design in the next class. Okay, thank you very much.